Calculus examples, the chain rule. This is video 16. In example 2, y equals the cube root of 5 minus 3x. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Example 2 from part 1 of video 13. Find the derivative of the function y equals the cube root of 5 minus 3x. This can be rewritten as y equals 5 minus 3x to the 1/3 after removing the radical. Solution. You should try method 1 first. Then complete the exercises in scene 3. If you have difficulties with method 1, complete method 2. Then try method 1 again. See reminder 1 in scene 7. Method 1. A direct method. The chain rule is the only differentiation rule that allows you to write down the derivative directly from the function you want to differentiate. The function is y equals 5 minus 3x to the 1/3. The function y is a bracket raised to a power. The derivative of y equals dy by dx equals the derivative of the bracket raised to the power using the power rule is 1/3 of 5 minus 3x to the 1/3 minus 1 multiplied by times the derivative of d by dx of the function inside the bracket, which is 5 minus 3x. So substitute 5 minus 3x. Therefore, dy by dx equals bring down 1/3 of 5 minus 3x to the 1/3 minus 1 is minus 2/3 times d by dx of 5 minus 3x is minus 3, and thus dy by dx equals 1/3 times minus 3 is minus 1. Now replace minus 1 with minus, then bring down 5 minus 3x to the minus 2/3 equals minus 1 divided by 5 minus 3x to the 2/3. See reminder 2 in scene 8. The instructions above were first introduced in video 14. Now complete the 4 exercises in scene 3 using this method. In each question, write down the derivative directly from the question, omitting the line of working between them. To review the above working, you should pause this video now. Exercises. Applying method 1 to functions that involve a bracket raised to a power. Write down the derivative of all 4 of the following functions using method 1 in scene 2. If you write the above questions on a piece of paper, then display method 1 in scene 2, you can use it as a template to find the derivatives. To find each derivative using method 1 before seeing the answers, you should pause this video now. To simplify each derivative before seeing the final answers, you should pause this video now. To review the questions and answers, you should pause this video now. Finding the derivative. Method 2. A set procedure. The chain rule is: so before the chain rule can be applied, the function z must be identified. Identify the function z. Fact 1. If y equals a bracket raised to a power, then z equals the function inside the bracket. The function is: so y equals a bracket with 5 minus 3x inside raised to a power which is 1/3, then z equals the function inside the bracket, which is 5 minus 3x. Therefore, z equals 5 minus 3x. The fact stated above was first introduced in video 14. To review the above working, you should pause this video now. The set procedure. I created the following set procedure so that once my students had identified z, they would always be able to obtain the correct derivative. See Reminder 1 in Scene 7. The question is: from Scene 4, z equals 5 minus 3x. Then y equals, since z equals 5 minus 3x, 5 minus 3x to the 1/3 becomes z to the 1/3. So dz by dx equals the derivative of 5 minus 3x, which is minus 3, and dy by dz equals the derivative of z to the 1/3, which is 1/3 z to the minus 2/3. The chain rule from scene 4 is so dy by dx equals dy by dz is 1/3 z to the minus 2/3, because dy by dz equals 1/3 z to the minus 2/3 times dz by dx is minus 3, because dz by dx equals minus 3. Therefore, dy by dx equals 1/3 times minus 3 is minus 1. Now replace minus 1 with minus, then replace z to the minus 2/3 with 5 minus 3x to the minus 2/3, because z equals 5 minus 3x equals minus 1 divided by 5 minus 3x to the 2/3. See reminder 2 in scene 8. You should complete the exercises in scene 3 using method 2 now, and then try method 1 again. To review the above working, you should pause this video now. Once you understand method 1 in videos 15 to 19, you will be able to find the derivative of any other function that requires the chain rule, because every function you will have to differentiate will be similar to one of the functions in these videos. Most of my students were able to use method 1 very soon after I started the topic, and with practice you can too. However, if you have difficulty understanding method 1, then work through method 2 first. In this method, you must first identify the function z in the chain rule formula. This is explained in scene 4. After you have identified z, you can complete the set procedure in scene 5. See reminder 1 in scene 7. When solving questions from your textbook similar to the example in this video, you will find it helpful to display scene 2 for method 1, or scene 4 followed by scene 5 for method 2, so you can use them as templates to find the derivative. You should then find this topic simple and beautiful. Cheers. Do not forget to check your answers with the answers in the back of the textbook. Reminder 1 displayed without commentary. To review the above reminder, you should pause this video now. Reminder 2 displayed without commentary. To review the above reminder, you should pause this video now.